Hello students, I am Manoj Kundare working as the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video lecture, we were studied the details about the PSW register of 8051 microcontroller. The PSW stands for Program Status Word Register. It is also called as the flag register. The link of the previous video lecture is available in the description box. Please check it. In this video lecture, we are going to see the stack and stack pointer register of 8051 microcontroller. Here is the diagram of internal RAM organization of 8051 microcontroller is shown. Here is there are 4 register banks which contains total 32 bytes, 16 bytes of bit addressable RAM and 80 bytes of general purpose RAM. That means there are total 128 bytes of internal RAM. There are 4 register banks, out of which the register bank 0 is selected automatically, or it is also called as the default bank. The RAM addresses from 00H to 07H is occupied by the register bank 0. Let's see what is meant by stack. The stack is an area of internal RAM used by the CPU to store the information temporarily. That means in the internal RAM organization, the stack area is located. The stack is the reserve part of the RAM. To point out the stack area, the CPU uses a register known as stack pointer register. Next, the stack pointer register of 8051 microcontroller. By using the stack pointer register or by using SP register, we can access the stack. The stack pointer register is an 8-bit register. That means it can take values from 00H to FFH. Here H represents the hexadecimal value. When the 8051 microcontroller is powered up, the stack pointer contains the initial value 07H. This is a very important statement here, that after reset or after powered up, all the registers in 8051 microcontroller are having the value 00H in it. But the stack pointer is the only register which has the value 07H after reset. Why this happens? Because we already seen that after powered up, the register bank 0 is selected automatically and it ranges from 00H to 07H. And the most important thing about the stack is the stack pointer always points the topmost field level in the stack. That means whatever in the stack, let's see, this is the cross section of the stack, and consider here is A stored, here is B stored, here is C stored, and this is the empty position. Then the stack pointer represents the topmost field position in the stack. Here in this is the topmost position where data is stored. Hence the stack pointer register shows this position. Okay, I hope you understand this concept. Now next, the stack pointer register of 8051 microcontroller, there are two operations are associated with the stack. First one is push operation and second one is pop operation. The stack follows the rule of last in first out or first in last out. I hope you all know what is meant by last in first out. Let's take a short look on the last in first out. Consider a register, any register which is performing last in first out. That means suppose it contains A, it contains B, it contains C, what is mean by last in first out? That is, whatever is stored in this register at last is gone the first. That means the first A is stored, then B is stored, then at last C is stored. This is the last word which is stored, and this goes out first. After C goes out B. After B goes out A. This is called as the last in first out operation. I hope you understand the basic concept about the last in first out operation. Now let's see the details about push and pop operation. The storing of CPU register data in the stack is called as push operation, and loading the contents of the stack back into a CPU register is called as pop operation. That is, in other words, a register is pushed onto the stack to save it and popped off the stack to retrieve it. That means, in other words, we can also say that if this is a stack area and when we save the contents into the stack, then at the time this time push operation is performed, and if the data is taken out from the stack, then the pop instruction is required. Let's see the details about each push operation and pop operation. First, let's see the push operation. During each push operation, the stack pointer is incremented by 1. That is, the stack grows up as data is stored in it. For example, the register R1 of bank 0 contains the data 25H and stack pointer initialized at 07H. To save the contents of R1 onto the stack, the push instruction is executed. Let's see this example on a diagram. In this diagram, we can see the cross section of the stack. Here is the memory locations are shown: 07H, 08H, 09H, 0AH, 0BH. Okay. Now we previously learned that after reset, the stack pointer having initial value 07H. Now the register R1 of register bank 0 contains some data 25H. Now this data is need to be loaded into this stack. For that purpose, a push operation is performed. Before loading of the data, the stack pointer represents the location 07H. We learned that in push operation, when we data load into the stack pointer is incremented by 1. Here is after push, the stack pointer is incremented by 1. First it is at 07H. After loading data, it having the value 08H, and the contents of R1 are loaded into the 08H. I hope you understand the push operation. Similarly, we can see the pop operation. During pop operation, the stack pointer is decremented by 1. The pop operation is opposite to the push operation. For example, the stack location 0BH contains the data 54H and stack represents the location 0BH. To save the contents of 0BH into the register R3 of bank 0, pop operation is performed. Let's see this example on a diagram. Here is the memory locations 07H, 08H to 0BH are shown. The stack pointer always shows the topmost fill position, and here is the topmost fill position is at 0BH, hence the stack pointer is also at the 0BH. Now we need to load this content of 0BH into the register R3 of register bank 0. For that purpose, the pop operation is executed. We already learned that during the pop operation, the stack pointer is decremented by 1. That means After the pop operation, the stack pointer having value 0AH, first it having value 0BH, and after pop operation it having value 0AH, that means it is decremented by 1, and the contents of this location is loaded into the register R3 of register bank 0. Okay, I hope you all understand the basic difference between push and pop operation. It is very simple that if the data is loaded into the stack, then push operation is required, and during each push operation the stack pointer register is incremented by 1, and if the data is taken out from the stack, then the pop instruction is required, and during each pop operation the stack pointer register is decremented by 1. I hope you all understand the concept of stack pointer, and the operations associated with the stack pointer register, that means push and pop operations. Thank you, students.